invests $5,000 in a GIC. Each year he gets 3% interest at the beginning of that year. Consider the GM. Blah, blah. Okay, what's the growth factor if you get 3% interest every year? 1.03, right? 30% would be nice, but I don't think banks will give you 30%. 1.03. Okay. What a product which represents the value of the investment after 1 year. Okay, so basically, how much does he have after 1 year? So we're going to say T1, which is our A value, which is the amount you invest, $5,000, times the interest rate. Now, we're not going to I actually don't want to, well, let's multiply it out. Who cares? I might as well figure that out. Where's my calculator? $51.50. He earns $150 in interest. Okay. All right. Now, how much does he have after 2 years? What do I do? So you would go this number, right? That's how much you have after 1 year. And you would multiply it by 1.03.
Wouldn't 5,000 be the A value?
No, because it's after. You're going to see in a sec. All right. 5150 times 1.03. What does that equal? I don't know what that equals. 5304.5? 5304.5. So the first year you earned 150 in interest. The second year you earned 154.5. An extra 450. All right. Now we're going to write a formula for this geometric series, because essentially what we've created is we're doing this. I'm going to write it over here in pink. This is after 1 year. After 1 year, you have 5150. After 2 years, you have 5304.5, and you can keep going on. Okay? So I'm going to use the formula Tn is equal to ARn minus 1. Now, what's our A value? No. Because the A value is the amount after 1 year, right? So, but I'm not going to write it as, that's not what I want to do. I'm not going to write it as 5150. What I'm going to do is I'm going to write it as this, 5,000 times 1.03. That's the same thing. Everybody agree with that? You're going to see. There's a reason. So I'm going to go 5,000 times 1.03. Okay. What's my R value? So this is A. Let me be clear about this. This is A. All right.
Would our R value be the number of years?
What's R represent? Growth factor, which we said is 1.03. Okay. Yep. You could, but hang on. 1.03 to the n minus 1. Okay, can we clean this up? Because it looks ugly right now. All right. It's not 1.03 squared. It's like this. You're all on the right track. You see that these are the same. If I had x, I'll just say x, and then I had x to the n minus 1, what would I do with those two things? Add the exponents, right? Because the bases are the same. No. It would just be n, because it's going to be 1.03, 1 plus n minus 1. Because this has an exponent of 1, right? So what happens to the ones?
Cancel. They go there.
They go away. So you get 5,000 1.03 to the n. The minus 1 goes away because your initial a value has that 1.03 or the r factor in it already. Okay, so that's why when it says after, and yesterday when I gave you this formula, what? See, the n minus 1 is gone. It's only when it says after 1 year, because your initial a value is not the amount you invest at the beginning. The a value that starts the geometric is how much you have after a year or after a bounce or whatever. Why the minus 1 goes away. So this is actually leads to what's called and this number here is how much you invest or whatever, right? Then it sort of makes sense. I invest this amount. If I do it for an n number of years, I can get how much money I have. This is the compound interest formula, which actually is written this way. A is equal to P. P is the principal, how much you invest. 1 plus the percentage to the n. And this is the number of years. And notice it's the amount you have after. It's that key word is after. Okay? This is principal. Whoops. Or the amount you invest. Amount invested.
Is n always here?
Yeah.
Okay.
So A is the final amount, like how much you have at the end. So for example, if we do the same question, we're not going to do 1 year and 2 years. We'll just do 10 years. I want to know if I invest $5,000 with a 3% return every year compounded annually. We're not doing anything other than compounded annually. How much money do I have after 10 years? Well, I can just plug it right into this formula. A is equal to the amount I invest, the principal, the R value, 1.03, to the power of 10. How much do I have? $6,719.58. So you earn $1,700 in the 10 years in interest.
That's not great.
It's not great, but you didn't do anything. The money just sat there, right? If you compound it, yeah, like over a month or week or whatever, right? But yeah. Okay. This isn't a financial class, but I understand your points. Yes. You're getting interest in this case every year, but you could do it monthly, so that interest is generated monthly. They calculate it and then give you that. So the more compounding periods you have, the more money, the faster you grow your money. So if you did it monthly, you'd earn more than that. Okay, so compound interest formula. That's why when it says the word after, you can make the n minus 1. The minus 1 goes away and it's just to the power of n. Okay? Here are the questions. I'm telling you right now, you're not going to get them all done because I'm going to move on to the next lesson, but that's okay. So basically you're doing 10 and then 12 to 16 and 20. Let's write it that way. 10, 12 to 16, and 20.